When you're given a lactone cyclization problem where you've got two OH and two methyl ester groups in the same molecule, it's possible to form two different kinds of products. You'll know which one you're dealing with because you'll have those products given to you, so you'll know how to handle the cyclization steps. Now, the two different ways of doing it involve taking the OH that's nearest to each of the methyl ester groups and joining them together. And that way we end up with two separate and distinct rings joined by a carbon-carbon bond. The other way of doing it involves an overlap. So the OH that's further away joins with the methyl ester group that's further away, and this OH that's further away joins with this methyl ester group. And what we end up with is what I'm calling a fused ring system, where each ring shares a common carbon-carbon bond. Alright, so those are the two ways it could possibly go, and you'll know which way it's going to go because you'll be given the products. Now what I'm going to do is I'm going to handle the top one first. So I'm going to get rid of this other one. And I'll show you how the mechanism for this will go. Alright, so the first thing I will do is draw this out. In the first step, H plus gets added to one of the C double bond O's. It doesn't really matter which one we start with. And the H will go on the O and the plus will go on the C. And what we can do here is look at what we're doing up here, and that'll follow the same cyclization pattern to give us the products we need. And what I will do is go ahead and number this as well. There'll be 1, 2, 3, 4, 5, 6. And the numbering will be from where I'm drawing the tail of the arrow to where I'm drawing the head of the arrow. And that will enable me to figure out how big the ring will be from this step as well. So we're looking at a 6-membered ring. And this will be the 1 position. There'll be 2, 3, 4, 5, and 6. And to the 6th position, you can see that we're going to have an OME and an OH. And to the 1 position, we'll still have our hydrogen connected, and the oxygen will have a positive charge. And off the 3 position, we'll have the rest of the compound, and that has remained unchanged up to this point. In the next step, we're going to have the proton transfer. Now the proton will always be transferred to the leaving group. We know what the leaving group is, it's methanol, so we know that the proton will be transferred to the OME group. And of course, the leaving group can also be identified by knowing what's attached to a C double bond O, which is an OMe. Alright, so we'll do that. We'll put the proton on there. Let's keep it consistent. And then we can reform the C double bond O and kick out the leaving group. And that completes the cyclization step. We've got our methanol, we'll have H plus as well. And you can go ahead now and use this H plus to react with the C double bond O on the other side. And then we can have the cyclization. And again, we can do our numbering. And you can see that this will be a six-membered ring. And this will be position 1. This will be position 6. Go ahead and fill in the rest of the numbers. And you see the 3 there matches what we would expect it to match. 4 and 5. And on position 6 we're going to have the OH and the OMe. And on here we'll have the hydrogen and a positive charge. The proton will get transferred to the OMe as it did before. and then the C double bond O reforms, kicks out the methyl group. Make a little bit more space here. Alright, and that gives us our second ring along with H plus and methanol. Alright, so that's how we handle two rings that are joined together by a carbon bond and not fused.